In this video we're going to look at number patterns, and we're also going to look at how to create and use a formula that connects two sets of numbers. Now, to start off with some really basic stuff, we're going to look at this set of numbers here, and we've got 4, 8, 12, 16, 20, 24 and 28, and I've left a blank space here. This is the something times table. Now that should be fairly straightforward for you to kind of answer, obviously. Everyone I hope would recognise that as the 4 times table. Again, going down to this one, leave a blank space here just now. 6, 12, 18, 24, 30, 36 and 42. Again, hopefully everyone would recognise that as being the 6 times table. And 3, 6, 9, 12, 15, 18, 21. Hopefully everyone recognises that as being the 3 times table. What I'm now going to do is I'm going to fill in these missing questions here. So I'm going to try and fill in parts B, D and F with a new number pattern, and I want to see if you can still answer that question. So here we can see the new number patterns, and if we look at part B here, it's 5, 9, 13, 17. And what you'll probably recognise here is this isn't one of your times tables that you know. We knew this was the 4 times table because it started with 4 and it went up in jumps of 4. So the fact it went up in jumps of 4 is what we're actually interested in. This number sequence here, 5, 9, 13, 17, it also goes up in jumps of 4. That actually means it's connected to the 4 times table. Now, if I was to write this is the 4 times table, at the moment this sentence is not correct. This is definitely not my 4 times table. But remember, if we compare it to the 4 times table above here, how would I change this 4 times table to turn it into these numbers here? How do I get from 4 to 5, 8 to 9, 12 to 13 by doing the same thing each time? What am I having to do? 16 to 17, 20 to 21. You can see that I'm going to have to take the 4 times table and add on 1 to get this each time. So this can be thought of as the 4 times table plus 1. Okay, in other words, our 4 times table's up here. This is 1 greater than every single one of these numbers. So this is the 4 times table, but with this extra condition plus 1. Now, again, the 6 times table started with 6 and it goes up in jumps of 6. If we look at this number sequence here, though, you can see this is not one of your recognised times tables. So, again, what we're interested in is what does it go up in jumps of? Which times table is it connected to? So, 8 to 14 is a jump of 6. 14 to 20 is a jump of 6, 20 to 26 is a jump of 6. So it's going up in jumps of 6, which means it's connected to my 6 times table. But again, that sentence on its own is not true. This is definitely not my 6 times table. My 6 times table is this set of numbers here. So how do I change this 6 times table to get these numbers down at the bottom? How do I go from 6 to 8, from 12 to 14, from 18 to 20 by doing the same thing each time? And you can see here, 6 plus 2 is 8, 12 plus 2 is 14, 18 plus 2 is 20. So to make this correct, it's the 6 times table plus 2. Okay, so this is my 6 times table with 2 added on to every number. And again, if we look at this, this is my 3 times table. This is not the 3 times table, but it goes up in jumps of 3, which means it's connected to my 3 times table. So I'm going to start off saying, well, that's the 3 times table, which we know at the moment is not true. My actual 3 times table above here, how do I get from this 3 to 2, from 6 to 5, from 9 to 8? This time, each time, 3 take away 1, 6 take away 1, 9 take away 1, 12 take away 1. Okay, so each time I'm having to take away 1, so that my rule here is that this set of numbers is actually the 3 times table with 1 taken off. Now, understanding that whatever a linear sequence like this goes up in jumps of is connecting it to a particular times table is kind of key to understanding the next kind of section. Now what we're going to do in this bit here is we're going to now look at how do we connect together using a formula these kind of 2 letters in this table, or this number to this number, and this number to this number, this number to this number, and so on. So the question here says write a formula to find V if I know the value of n. In other words, how do I fill in the bottom number in this table if I know the number at the top? So say for instance I want to continue this, I had 9 there, how would I work out what this number here is? Now, the first thing is to look at the language of the question. It's asking me to write a formula to find V. If I'm being asked to write a formula to find V, then it makes sense for that formula to start off with V equals. Okay, if you're thinking about the area of a triangle, you would start the formula with A for area equals volume of a cuboid, you'd start with V for volume. Okay, so the thing we're looking for, the subject of the formula, goes at the front. Now, on the last slide, we looked at our kind of number patterns or times tables, and we realised that if a number sequence goes up in certain jumps, it's connected to a particular times table. So if you look at the values of v down at the bottom here, 7 to 11 to 15 to 19, what we'll notice each time, hopefully, is it's going up in jumps of 4 each time. So 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19. So because it goes up in jumps of 4, it means it's connected to the 4 times table. Now, obviously this is not the 4 times table, but it just means, we're going to have to use multiplication by 4 as part of our formula. So let's use our multiplication by 4. So we're going to do 4 times something, and we're going to take 4 times this top value here and see where that gets us. So 4 times the other letter in the formula, 4 times n. Now, at the moment, we want to see if this formula holds true. Okay, so what this is saying at the moment is the v value, the number at the bottom, is equal to 4 times the n value. So in other words, 4 times this top number should give me this bottom number. Now that at the moment doesn't work. 4 times 1 is 4, it's not 7. So what we're going to do is I'm going to write above this table what would happen if I just did the 4 times n, 4 times this, 4 times this, and 4 times this, for instance. So I'm going to write them above. 4 1s are 4, 4 2s are 8, 4 3s are 12. That's what my formula is currently giving me. It's telling me that v is equal to 4 times n, but this is 4 times n up here, and this is the values of v down here. That obviously doesn't match up. So how do I make it match up? I needed some sort of corrector here to do that. What do I need to do to the 4 to turn it into a 7, the 8 to turn it into an 11, and the 12 to turn it into a 15? Now we're having to do the same thing each time here, because this formula should work for all of these. Hopefully what you'll notice is 4 plus 3 is 7, 8 plus 3 is 11, 12 plus 3 is 15. So to finish off that formula, I need another step, which is add on 3. Now, let's just check if that works. So we're saying the v value, the number at the bottom, is 4 times the n value, which is the number at the top, and then add on 3. So 4 times 1 is 4, plus 3 is 7. 4 2s are 8, plus 3 is 11. Let's try it for one of these ones up here. 4 8s are 32, plus 3 is 35. So it actually works for all of these values. We'll now look at the second one now. This time we're connecting two letters, P and Z together. And again, looking at the language of the question, we're being asked to write a formula to find Z. So if my formula is going to help me find Z, then it makes sense that Z is the subject, or the formula starts with Z equals. We're then going to find out which times table we're connecting into here. So what is this going up in jumps of along the bottom? So each time 3 to 8 is a jump of 5, 8 to 13 is a jump of 5, 13 to 18 is a jump of 5. We're adding on 5 each time. Now remember, if a sequence like this goes up in jumps of 5, it means it has a connection to my 5 times table. If it has a connection to my 5 times table, then multiplication by 5 is part of the process. So I'm going to start off by multiplying by 5. So 5 times the other letter, so 5 times p. So I would just write that, remember with algebra, 5 times p I would just write as 5p. Now what the formula at the moment is saying is it's saying that z is equal to 5 times p. Is that true? Is this z value just 5 times the number at the top here? So let's try that. 5 times 1 is 5, and that doesn't match up with my z value. So what I'm going to do is I'm going to just take the 5p part, and I'm going to work out what happens if I use that. I'm going to do 5 times that, 5 times that, 5 times that, and so on. And I'll write them in red above. So 5 1s are 5, 5 2s are 10, 5 3s are 15. What I've now got to do is work out what my correcting number is. Okay, so how do I move from this 5 down to this 3? How do I move from this 10 down to this 8? How do I move from this 15 down to this 13? In each case, I'm going to have to subtract 2. So the last part of my formula is then take away 2. So we know it goes up in jumps of 5, so it's 5 times p. If I actually do 5p's, I get these numbers here. And then I'm going to have to work out how to get from those numbers to my z value so this formula works. So I need to take away 2, take away 2, take away 2. And again, we can check that works by doing, say, 5 7s are 35, take away 2 is 33. So it works for the other values too. I'm going to give you a chance to try a few questions here yourself. So if you want to try these questions, pause the video, and then when you're ready to go over each one, just press play. Okay, so we'll go quickly through these and we'll see if we can pick up the correct answer for each one. So part A, find a formula for t. So we start with t equals. Next thing, what's it going up in jumps of? It's going up in jumps of 3, so 3 times the other letter, 3 times r. If I then do 3 times r, in other words 3 times each of those values, where does that take me? So 3 1s are 3, 3 2s are 6, 3 3s are 9, and then if I'm saying that t is equal to 3r, that's not the case. 3r is these numbers at the top. I still need to add on 4 to get to t. 6 plus 4 is 10, 9 plus 4 is 13, so plus 4. Next question, find a formula for b. So again, we're going to start off with b equals. Next step is what's it going up in jumps of? It's going up in jumps here of 8. So we're going up by 8 each time. So it's going to be 8 times the other letter, 8a. And if I do 8 times a, I'm going to end up with 8, 16 and 24. And then I need the correction number to get from my 8 to my 5, my 16 to my 13, and my 24 to my 21. Now each time there I'm going to need to take away 3. So that finishes off the formula over here. So b equals AA, take away 3. Right, this one here, find a formula for E if I know W. So it's a formula for E, so it's going to start E equals. We're going to work out what it goes up in jumps of here. It's going up in jumps of 2, so connected to the 2 times table, so 2 times the other letter W. And then we'll just write out what 2W gives us. So my W's are along the top here. 2 times each of these is going to be 2, 4, 6. Now, I still need to work out how I'm going to get from these numbers at the top down to these numbers at the bottom. So 2 to 3, 4 to 5, and 6 to 7. Each time I'm having to add on 1. So the last part of my formula, plus 1. I'm just going to write down the last few answers so you can just quickly check over them. This one here, a formula for D, it's going to be D equals, going up in jumps of 3, so it's 3 times the other letter F, and then 3 times them is 3, 6 and 9, and my correction number to get from these then, I need to add on 1 each time. Next one, find a formula for K. So because it's a formula for K, it's going to start K equals. It's going up in jumps of 5 here. So 5 times table it's connected to, so that's 5j. And we're going to write the values of 5j along the top. So 5 1s are 5, 5 2s are 10, 5 3s are 15. And my correction number each time to go from there to there to get the value of K. Once I've done 5j, I still need to add on 1 each time. So plus 1 is the last part. Next, a formula for n. So that's going to start n equals. This one's going up in jumps of 10 along the bottom. So 10 times the other letter p. And again, we're just going to quickly put in what 10p gives us. The p values are along the top here. 10p is going to be 1 times 10 is 10, 20, 30. And then I need my correction number to go from each of these. So to go from 10 to 11, 20 to 21, 30 to 31. And again, it's turned out to be plus 1. Lastly, find a formula for V. So it's going to start off with V equals. This one is going up in jumps of 6 each time, so it's connected to my 6 times table. So 6 times the other letter, which is C, 6C. And again, what we're going to do is we're going to put 6 times C along the top, so 6 times each of these C values. So 6 times 1 is 6, 6 2s are 12, 6 3s are 18. And then look for my correction number. How do I get from that value at the top, from my 6C values, these are all 6C, down to the value of V? I'm still going to need to do 6, take away 3, 12, take away 3, 18, take away 3. So the last part of my formula here will be take away 3. Now we're going to look at creating a formula that connects two things together and using it to solve problems. So here we have a bit more of a kind of practical example. We've got a pattern made up of dots and lines, so a dot followed by 4 little lines around it. Shape 2 has 2 dots and let's see, 1, 2, 3, 4, 5, 6, 7 lines around it. And shape 3 is again dots and lines. And you can see there's a pattern forming here. You can imagine what shape 4 would look like. So what we're going to do, first part says complete the table. So if I was going to complete the table here, if the number of dots is 1, what's the number of lines? Well, 1 dot required these 4 lines, so I can fill that in quite easily. If I look at the next one, 2 dots here requires 1, 2, 3, 4, 5, 6, 7 lines. So 7 lines there. And again, looking at the last one, the 3 dots here requires 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 there. Now what you should see is, not only would it be easy to draw out the next pattern if I was asked, for instance, I know the shape 4 would look like this. I would have basically 4 of these boxes, each with a dot inside them. And what I'm doing each time is I'm having to only add on, for every dot I add on, so this little dot I've added on the end here, it's only required 3 extra lines to the previous pattern. So this number pattern is going to continue like this. It's going to go up in 3s each time for these 3 extra lines we have to add. So I'm going to finish off this table by continuing the pattern and going up in 3s. So 10, 13, 16 and 19. So that's part A done. Part B asks us to write a formula for calculating the number of lines if you know the number of dots, and it also has a letter representing each one. Now the number of lines is L, the number of dots in this case is D, and it tells you that there in the question. Now this is what we've been practicing on the previous slide, so what we need to do is first of all work out how we're going to start our formula. So again, the language here is really important. Write a formula for calculating the number of lines L. So if it's a formula to calculate the number of lines L, then it's going to start off with L equals. Okay, we're then going to look at the times table we're connecting into here. So this is 4, 7, 10. It's going up in jumps of 3 every single time. So because it goes up in jumps of 3, it's connected to my 3 times table. Therefore, multiplication by 3 is part of the formula. So 3 times, as before, the other letter, which is D, and we'll see if that works or not. So are these L values just 3 times the D values? 3 times this D value here. 3D is 3. That's not the same as 4, so we need a correction number. So let's try and just do 3 times D with these first 3 numbers here. So 3 times this is going to give us 3. 3 times 2 is going to give us 6. 3 times 3 is going to give us 9. And then I need to work out how I'm going to finish off this formula here. What's the connection number each time? How do I connect the 3 to get to the 4, the 6 to get to the 7, and the 9 to get to the 10? And what you'll hopefully see there is we need to add 1 each time. So that's the last part of my formula. So that's a formula to calculate the number of lines if I know the number of dots. In other words, the number of lines is equal to 3 times the number of dots, add on 1. Let's see if that works. 3 times 6 is 18, plus 1 is 19. Now, parts C and D are 2 different styles of questions, but they're basically done mostly in the same way to start off with. The first thing we need to do each time is we need to write out our formula. So for part C there, it says if a shape has 24 dots, how many lines does it have? Now, what we've done in part B is we wrote a formula connecting the number of lines and the number of dots. Now, the reason this is part C to this question here is because we need to use the formula we created in part B in order to answer that. So we're going to write that down first. So L equals 3D plus 1. And what we've got here is the number of lines equals 3 times the number of dots plus 1. Now the question says, if a shape has 24 dots, and that's important here, it's got 24 dots, how many lines does it have? So we know the number of dots is 24. Now which of these 2 letters stands for the number of dots? Remember, number of dots is D, so this is the number of dots here. Now we have 24 dots, so we have 3 times D is actually 3 times 24. So we're going to finish this off by going L equals 3 times 24. Okay, we're replacing the D for dots with the number of dots, and then add 1, and we can quickly work that out. 3 24s are 72, and then add 1, which is 73. So that would be 73 lines. And you can see that's quite useful because it allows me, if I know the number of dots in the pattern, to work out the number of lines I would need to draw around them. Now, for part D, a similar idea. If a shape has 61 lines, how many dots does it have? So, again, we've made this formula up, which connects the 2, so that's definitely our starting point. We're going to write that out. So, L equals 3D plus 1. And again, looking at the language of the question, it says a shape has 61 lines. Now, that means it's giving us a piece of information about one of these 2 letters. That's 61 lines. Which letter here represents the number of lines? So remember, its number of lines is L, so this is the number of lines here. The question tells me I've got 61 lines, so that L is actually 61, and I can replace that L with 61 here. and I'll just write out the rest of the formula. Now this is slightly different than the last example, because the last example, the formula was designed to find the number of lines because it started with L equals, so I just needed to substitute that in and calculate it. In this question it's slightly different, because when I substitute that in, there's no calculations I can do. What you see you're left with here is you're left with an equation. So what I need to do is I need to solve that equation. Now to solve that equation, what you might feel more comfortable doing is swapping sides. So 3d plus 1 equals 61. And then just solving as you'd normally solve an equation. We're going to take away 1 from this side and take away 1 from this side. That's going to leave me 3d equals 60. And then I want to get d on its own, so I need to undo this multiplication by 3. So I'm going to divide this side by 3, and therefore I have to also divide this side by 3. So this side divided by 3 gives me d, and this side divided by 3 gives me 20. And it tells me now there d is 20, so how many dots does it have? Well, if d is 20, then it's got 20 dots. So I can just write that out here, 20 dots. Okay, and that is how we create a formula connecting two values like this. We've practiced that. And then how we can use a formula both ways. If we're given one of the pieces of information, how do we find the other? And remember, the first step will always be write out the formula and then work out which letter you're being given information about and replace that letter or substitute that letter. And then decide if it's just one you can evaluate or if it's an equation you need to solve.